Good morning, students. Chapter 6, Electromagnetic Induction. In last lecture, we have discussed about Lenz's law, which gives direction of induced EMF and direction of induced current. Now, in this lecture, we will see one important topic, that is motional EMF. Yes, you have to remember one flow. Which flow? The EMF is produced due to change in flux. EMF is induced. EMF is induced due to change in magnetic flux. Due to change in magnetic flux. Okay, this point you have to remember throughout this chapter. Okay, the EMF is induced due to change in magnetic flux. What is equation of magnetic flux? See, phi is equal to magnetic flux. Phi is equal to, it is VA cos theta. It is VA cos theta. Clear about this? It is equation of magnetic flux. Phi is equal to, it is VA cos theta. Theta is angle between V and A. Theta is angle between V and A. Clear about this? Okay. What is equation of induced EMF according to Faraday's law? According to Faraday's law, induced EMF E is equal to minus d phi upon dt. The negative sign indicates Lenz's law. The EMF is induced such that it opposes change in magnetic flux. Now, what do you mean by motional EMF? Motional means motion. Due to motion, EMF is induced. How? Due to motion, EMF is induced. How? See, I will draw one figure. Here we have uniform magnetic field. Here we have uniform magnetic field perpendicular to board going inside. Here we have uniform magnetic field perpendicular to board going inside. Clear about this? Okay, it is magnetic field perpendicular to board going inside. So yes, here first of all I am going to write. Okay, let uniform magnetic field is normal to plane going inside. Okay, it is uniform magnetic field. In this uniform magnetic field, I am assuming one U-shaped frame. One U-shaped frame like this. It is one U-shaped frame. Clear about this? It is one U-shaped frame. On this U-shaped frame, yes, there is one wire PQ. There is one wire PQ which can easily slide between these two parallel arms. Clear about this? Yes, this PQ wire can easily slide between these two parallel wires. Like length of this PQ wire is L. Length of this PQ wire is L. So uniform magnetic field going to perpendicular inside. This loop, this U-shaped frame is placed perpendicular to magnetic field. See here, U-shaped frame is placed normal to magnetic field as shown in figure. Okay, PQ wire of length L. A wire PQ wire having length L can slide between two parallel arms. This wire PQ can slide between two parallel arms. Clear about this? Yes or no? See, why it is named motional EMF? First of all, we will see this. Let this PQ wire, okay, see, these two ends are open, but this PQ wire encloses some area here. This PQ wire encloses some area here. Yes or no? Yes, this PQ wire encloses some area here. If I move this PQ wire in this direction with uniform velocity v, if I slide this PQ wire with uniform velocity v towards right, then see, this area enclosed by which is enclosed by wire continuously changes. If I slide this PQ wire towards right, so see, area increases, and yes, if area increases, there is change in flux, and due to change in flux, EMF is induced. Clear about this? Again, we have a U-shaped frame. A PQ wire is free to slide between these two parallel arms. If I slide this wire PQ with uniform velocity v towards right, then this area enclosed by wire with frame, continuously increases. So as there is change in area, there is change in flux, and due to change in flux, according to Faraday's law, EMF is induced. And this EMF is induced due to motion of this wire PQ. Hence it is named motional EMF. Clear about this? So yes, how to write? See here, wire PQ, that it is wire PQ, and it is R, and here it is S. For example, here wire PQ encloses some area with frame RS. Here wire PQ encloses some area with frame RS. Yes or no? Now if wire PQ is moved with uniform velocity towards right, okay, area enclosed by wire with frame is changed, and therefore flux linked with this closed circuit, this PQRS closed circuit. So flux linked with closed circuit. Yes, we can say this circuit, closed circuit, PQRS changes, and therefore EMF is induced between two ends of wire PQ. Clear about this? So yes, it is theoretical portion. What happens? Again, this PQ wire can easily slide between these two parallel arms. Okay, if wire PQ is moved with uniform velocity towards right, area enclosed by wire with frame continuously changes. So flux linked with closed circuit continuously changes. So EMF is induced between ends of wire PQ. Now how to find this change in, or how to find this induced EMF? Now see, in this situation, let Let this distance is x. R3 is x. Okay. So as shown in figure, let distance between PQ and RS is x. PQ and RS is x. Clear about this? As shown in figure, let distance between PQ and RS is x. So at this time, okay, at this time, flux linked with closed circuit PQRS phi is equal to PQRS phi is equal to, what is equation of flux? It is BA cos theta. It is BA cos theta. Just B, that is uniform magnetic field. What is area of this PQRS? It is L and it is X. So just it is Lx. It is Lx. This PQRS surface is perpendicular to magnetic field. Magnetic field is going inside. This plane is like this. Its area vector is normal to A. Its area vector is normal to A. Yes, its area vector is normal to A. So yes, magnetic field and area vector, they both are in same direction. So here I can write it is cos 0. Here I can write it is cos 0. Clear about this? So yes, what is flux link? Flux is equal to it is BLx. Flux is equal to it is BLx. Now, according to Faraday's law, induced EMF, E is equal to minus d phi upon dt is equal to minus d upon dt. What is value of phi? BLx. Now see B, uniform magnetic field, constant. Length of this wire remains same. Length of this wire remains same. What changes? X. What is changes? X. Okay, initially wire is here at PQ. Now if after some time it is here at this point, that is P dash and Q dash, then yes, this distance changes. Means this value of X changes. Because X is distance between PQ and RS. PQ wire is continuously moving. So this distance X also changes. So here I can write this equation as E is equal to minus BL constant d upon dt of X. D upon dt of X. See, X in this direction, distance continuously changes with time. Dx upon dt, change in position with respect to time, it is nothing but velocity. Change in position with respect to time, it is nothing but velocity. So here dx upon dt, I can write V. E is equal to minus BLV. E is equal to, it is minus BLV. And if I want to write only its magnitude, then E is equal to, it is BLV. Mode of E is equal to, it is BLV. Where B, uniform magnetic field, L, length of wire, and V is velocity of wire. B is velocity of wire. And again, minus sign indicates presence of Lenz law. Minus sign indicates presence of Lenz law. Clear about this? So yes, it is about motional EMF. This EMF is induced due to motion of wire. EMF is induced due to motion of wire. Hence it is called motional EMF. This E is equal to B, LV is called motional EMF. Clear about this? So what is motional EMF? EMF is induced due to change in flux, but that change in flux is due to motion of this wire PQ. Clear about this? So if you are asked what is motional EMF and obtain equation of motional EMF in case when a U-shaped wire is placed normal to magnetic field. Normal to magnetic field. You have to write this theory. You have to write this theory. Now, if there is one question, is only one wire is moving in magnetic field, then is there any induced EMF? Is there any induced EMF? Yes, there is induced EMF. How? We will see. Now, we have discussed one case when wire PQ is sliding on U-shaped frame. Wire PQ is sliding on U-shaped frame. But if you are given only wire which is moving in magnetic field, then what happens? See, if wire PQ is moving with velocity v, if wire PQ is moving with velocity v, perpendicular to magnetic field, perpendicular to magnetic field. For example, see, here it is. Uniform magnetic field. Uniform magnetic field. Perpendicular to ball going inside. Uniform magnetic field. Perpendicular to ball going inside. Yes, uniform magnetic field. Uniform magnetic field. Normal to plane. Normal to plane inside. Okay. Now let in this magnetic field a wire, a conductor PQ is moving with velocity v in this direction. See here, length of this conductor is L. Length of conductor is L. Length of conductor is L. So see, this length is perpendicular to magnetic field and also this velocity is perpendicular to magnetic field. So length and velocity. Length and velocity. It is normal to magnetic field. Normal to magnetic field. Clear about this? Now what happens? See, conductor. Conductor means having positive charge fixed on lattice point, while electrons are free to move in random direction. Electrons are free to move in random direction. Yes or no? Yes. What is equation of force acting? See here, this conductor is moving with velocity v in magnetic field. Conductor moving with velocity v in magnetic field. Conductor having positive charges and negative charges. Simple. Positive charges and negative charges. So if conductor is moving, we can say positive and negative charges are moving with velocity v in magnetic field. Positive and negative charges are moving with velocity v in magnetic field. Positive and negative charges are moving with velocity v in magnetic field. Then what is force acting on charge moving with velocity v in magnetic field P? See, force acting on positive charge Q in magnetic field B with velocity v, with moving with velocity, force acting on positive charge Q in magnetic field B, moving with velocity v, moving with velocity v. What is equation of force? Yes, force F is equal to, it is Q V cross B. It is force F is equal to Q V cross B. Now, what is direction of force? In which direction this force is acting? Force is acting in direction of V cross B. Force is acting in direction of V cross B. V cross B. See here. velocity is in this direction, magnetic field inside, so force acting on positive charge is in vertically upward direction. Clear about this? Again, force is acting in direction of V cross P. Force is acting in direction of V cross P. Here in figure, velocity is in this direction, magnetic field perpendicular inside, so force acting on positive charge is in vertically upward direction. Yes or no? So yes, force acting on positive charge, it is in upward direction, means towards P. Force acting on positive charge is towards and P. Towards and P. Yes or no? Force acting on positive charge is towards and P. Simple. Then what is direction of force acting on negative charge? What is force acting on negative charge? Obviously it is in opposite direction. So therefore force acting on negative charge is towards and Q. Is towards and Q. Which charge is free to move? Obviously negative charge. Obviously negative charge. So yes, in this conductor there are positive charges and negative charges. Force acting on positive charge towards and P, they are not free to move, they will not move. But force acting on negative charge is towards and Q. Negative charge, electrons, they are free to move. So yes, electrons are accumulated at end E. So here we can say positive charge is induced. Here we can say positive charge is induced. Yes or no? So yes, what happens when this wire PQ is moving in uniform magnetic field with velocity V? This end P becomes positive and this end Q becomes negative. Clear about this? This end P becomes positive and this end Q becomes negative. Clear about this? All negative charge, not all, okay? Negative charge is accumulated at end Q and positive charge is induced at point P. Okay, negative charge is accumulated. Negative charge is accumulated at end Q. Okay, and positive charge is induced at end P. Positive charge is induced at point P. Then how to write? See here, negative charge is accumulated at end Q and positive charge is induced at end P. So now this PQ wire behaves as a cell. This PQ wire behaves as a cell. This PQ wire behaves as a cell, like this. It is P and it is Q and it is having EMF. Clear about this? Clear about this? So now what is EMF? How to induce equation of EMF? See here, in conductor there are positive charges and negative charges. This length is L. This length is L. This length is L. Yes or no? Yes. If force acting on positive charge is towards P, so from this end, if charge is moving, if free to move towards end P, or negative charge when it is moving from point P to Q, then what is work done? What is work done? Yes, see here, work to move charge Q from end P to Q. What is equation of work? Work W is equal to, work is equal to this force into displacement. What is force acting on charge? Q V cross V, and its magnitude is QVV. Its magnitude is QV. Why QVV? Because V and B, they are perpendicular to each other. V and B, they are perpendicular to each other. So it is QV. What is work to move charge Q from one end to another end? One end to another end means displacement is L. Displacement is L. And now just you know that what is potential difference? What is EMF? EMF is equal to work done per unit charge. Per unit charge. So EMF E is equal to this. Work done, it is Q VB into L upon per unit charge. So that is Q. So Q cut. So here it is E is equal to this BBL. E is equal to here it is BBL. The same equation. The same equation. So yes, if this wire PQ is moving in magnetic field, if moving in magnetic field, normal to it, its length and velocity both, then this wire PQ behaves as a cell. This wire PQ behaves as a cell. This wire PQ behaves as a cell having EMF PBL. Wire PQ behaves as cell having EMF. E is equal to BBL. E is equal to BBL. Clear about this? Clear about this? So see, you have to remember this situation. Magnetic field normally inside. Velocity in this direction, then P becomes positive and Q becomes negative if I change magnetic field. If I change direction of velocity, then yes, this polarity also changes. This polarity also changes. You have to find direction with the help of this. You have to find direction with the help of this, with the help of this equation, with the help of this equation. Clear about this? So yes, if you understand this situation, you can obtain direction of this P and Q in each and every cases. So yes, it is all about motional EMF. Now, one most important topic, that is this motional EMF is induced such that it opposes its cause. It opposes its cause. So what is presence of Lenz's law? That we will see in next lecture.